Welcome to our lesson on resistors in series. If we consider a very basic circuit, it is made up of two resistors and a voltage source. And there's only two ways that we can actually go about creating this circuit. The first one is to hook the resistors end to end. I'm going to start off by drawing our voltage source like a battery. The resistor looks like this. And if they are hooked up end to end, they look like they're side by side. So again, down here is our voltage source. And then this could be called resistor 1, and this one's resistor 2. So that's one way that we could draw a very basic circuit in an end-to-end series. Now the other way is to hook them up side by side for our resistors. So again, I'm going to start by drawing out our voltage source. So one resistor could be above here, and the other resistor can be below, and that is side by side. But we're going to focus on resistors in series for now, so consider three connected in a series. So that's going to look like the end to end. Here's our first resistor. Here's our second resistor, and here's our third resistor. We call this R1, R2, and R3. And for each resistor, we're going to consider Ohm's law. Sorry, I'm missing an M here. Ohm's law. So that is R is equal to V over I, where R is the resistance, V is the potential difference, and I is the current. So there's going to be a current and a potential difference. Because we have a continuous loop of the wire, the same current must flow through each resistor. And if the current is constant for each one, then each resistor must have a specific potential difference V, and each V can be defined using Ohm's law. So we're going to have V1 then. We're going to have V2 and V3. And the potential difference for the circuit will be the sum of the individual potential differences for each resistor. So the potential difference for the entire circuit is going to comprise from V1 plus V2 plus V3. And if we want to calculate that, then we can break it down even further as R1, the current, plus R2 times the current, plus R3 times the current. So now we're going to define the total potential drop V as the produce of our current I. And our equivalent is the equivalent resistance. We want to do this in order to simplify our three resistors so they appear as only one resistor. So the potential drop V is going to be the equivalent resistance multiplied by the current. And if we want to break that down more, that would be R1, the first resistor, times the current, plus R2 times the current, plus R3 times the current. Or in general, our equivalent resistance is all of the resistors we have added together. In this case, we have 3. And this can be extended to as many resistors as you like. So if you only have 2 resistors, they'll just be R1 plus R2. If you have 4, it'll be R1 plus R2 plus R3 plus R4. And we're just going to draw this diagram again. So let's say we have the 3 resistors. So that's R1, R2, and R3. This is equivalent to just having one really large resistor called the equivalent resistance, and that would be calculated as R1 plus R2 plus R3. So let's try this in an example. We have a 6 ohm and a 3 ohm resistor, so there's two resistors and they're connected in a series with a 12 volt battery. Assuming that the battery and the wire contribute nothing to the resistance, you want to calculate the equivalent resistance and the current. So let's just say our part A is the equivalent resistance. That's R EQ for the equivalent resistance. And we only have two, so that's going to be R1 plus R2. R1 is 6 ohms, R2 is 3 ohms, so that's going to be 9 ohms altogether. The next part, we want to find the current. So if you want to find the current, we're going to use V is equal to the equivalent resistance multiplied by I. But we want to find I, which is the current. So I'm going to divide both sides by the equivalent resistance. Okay, so V, the volt, is 12 volts for the battery. And then we just calculated the equivalent resistance in part A, which is 9. So 12 divided by 9 is 1.33 amps. And that's it. Let's do another example. Here I'm going to draw our diagram for a question. Okay, so we have a resistor here, another resistor here. We can call this one R2 and call this one R1. So R1 represents a 25 ohm resistor speaker with a power rating of 5 watts and is connected to a 24 volt source. We want to find what R2 is so that R1 can operate at maximum power. So the first thing we're going to do is we need to calculate the current I. And we're going to do this by using a formula that we've used in a previous lesson, in the electric power lesson, that P is equal to I squared times R. Now, we've been given the power rating of 5 watts, which is why I want to find an equation that has power in it. We also have the resistance, R, and it's 25 ohms, and we're looking for the current. So we're going to rearrange this and solve for I, which is P over R square rooted. Okay, so P was 5 watts, R is 25, and after we calculate this, the square root of 5 over 25 is 0.44 amps. Okay, so we just found the current. The next thing we're going to do is find the equivalent resistance for the circuit, given that we know what the current is now. So to calculate our equivalent resistance, that's calculated as V over I. And we know what V is. Our power source is 24 volts. And we just found the current I, which is 0.44 amps. So then our equivalent resistance is 55 ohms. Perfect. Now the last thing we need to do is find R2, because we have the equivalent resistance. We also have R1, so all we have to do is rearrange and solve for R2. So we're going to find R2, given that we know the equivalent resistance and R1. So we know that the equivalent resistance is equal to R1 plus R2. We know the equivalent resistance and we know R1, so if we want to solve for R2, it's going to be the equivalent resistance minus R1, which is 55 ohms minus 25 ohms, and that is 30 ohms as our final answer for R2.